So tonight we are going to start talking about auxiliary views. And auxiliary views are going to be views where we see things in their true size and shape. Now in week number 11, because that's where we're at, we're going to do week number 11, day 1, and then we're skipping over day 2 for week 11 and going to day number 1 for week 12. And I'm just eliminating some drawings from the day 2 part of week 11 so that we can keep on task and get the things that we need to cover. And the drawing is a little bit more difficult, and it's easier if when we did that in class. So starting with auxiliary views. So in day 11, there is a PowerPoint that I highly suggest that you watch and go through. There's a lot of slides to it, but there's some information that may make what we're going to do today a little more clear, and it would take me another 30 minutes for me to read the slides to you. So it's kind of senseless when I'm not there. So you can go through that. And I also have some notes online, and these are some notes that I would put on the board about how we're going to determine what our true size and shape is, and I'm going to pop back and forth to that so you can see that here in a minute. So basically, I'm going to share my screen so you can see my notes. So basically, you guys are looking at my notes, right? Yes? Okay.
Yeah.
So when we are looking at an auxiliary view or trying to create an auxiliary view, what we're trying to find is a surface where we see it in its true size and shape. So as you look what I have here on my computer screen here, so I have my front view of my object, I have my right side view and my top view. Now, when we see an object that's not its true length, we call that to be foreshortened. Whether it's full length or whether it's too long, it's seen longer or shorter, we still call that foreshortened. So when I look at this edge right here, I look at the edge of this inclined surface. So this inclined line here in the front view and this line here in the top view are the same edge. But in the front view, it's much shorter. I'm sorry, in the top view, it's much shorter than its actual, we call our true length line, where I see that edge on, I see the surface on its edge in true length. That this is where I can determine the actual size of the shape. So this is where I would create an auxiliary. So if I were trying to tell someone how to locate the hole that's going to go in this surface, I could not dimension in the top view or the right side view because they're not measuring flat. We want to measure it like it's laying on a table. If we can lay a ruler or a square on it and measure that. So otherwise, you know, it's a guesstimation. We're kind of guessing and drawing in air. So the first thing that we have to do is we have to locate the surface that we want to find out its true size and shape. We got to find it in its edge. So if we're looking in the front view, we can say here is our edge view of this surface. So we see it in the top, in the right side, and then the edge view, we just see it as an edge, so we know this is our edge view. We're going to make our auxiliary view, and our auxiliary view is always projected 90 degrees from the edge view. So if I were to throw a dimension on here, these lines would be 90 degrees, and I'm going to project these out at 90 degrees. So the length of my edge view is the same length that I have of what I would call my height in the front view now. And then we would measure back from a fold line. So we have these lines right here. Fold line number 1, we have fold line number 2, fold line number 3. Now fold lines are very important, and as we go on and get into EG110, we'll talk more about true size and shape and how to find those with multiple surfaces. But we need to find out the distances or how far this is. So we just know that this is the top and this is the bottom because we projected those views. Now to find out how far these are, we go back one fold line, or 2 fold lines. So we count this fold line as 1, go to the next view, 2. We could do it to the top view as well. We could go 1, 2. It's going to be the same. Now, these 2 fold lines could be in different locations. It doesn't matter. You put those in, you determine where they go. What is true is that they are parallel to that edge, so that I would take all the dimensions off one. I can't go back and use this one time and this one the next. You determine what it is, and you're going to use that one. Does that make sense? So it'll make sense. I'm going to show you paper at Rose. It'll make more sense when I do it in paper. So now what I haven't done here on the board is I would number this, and I would say, okay, here's number 1, number 2, and I would number my corners. And then I would number the corners here so that I could number them out. So I could dimension from the fold line to the first point. I'd bring that down. And then from the fold line, I would measure out that same distance, and that gives me my first point. Measuring from the fold line to my second point, fold line to the second point. So that's where, because we know this is its true width, we just don't know how long it is until we see that in that edge view. So our whole point of doing an auxiliary view is to see the shot, the object in its true size and shape. So when it's in its true size and shape, we know that, hey, I can put a dimension on that. So I'm going to go to our tutorial. So in week 11, day number 1, we're going to do tutorial number 1. Now I'm going to do that on paper. I printed it out, and I'm going to use some different colored paper for that. And I'm going to show you how that's going to work. And this typically works when we use paper and pencil, because people are like, I understand now. So let's do that. Let me switch cameras. Okay, now this might be easier if you go to speaker view on the projection, so that you see just my camera. And I'm going to do the same thing here. All right, so you're going to get this, and when you go into week number 11, this will be tutorial 7.1. You're going to download this file, and it's going to be just like this. So we need to create construction lines on the top and fold line number 1. Now, people get confused when they see this. So F is a fold line. H is the horizontal plane. Now here we also have the fold line, and the 1 is auxiliary 1 is going on that side. Now we're only doing this one out of 2 views, but if I had another view over here, this would have my F for my fold line, and this would say, this would have P for the profile view. So just to understand that H is for the horizontal plane, P is for the profile plane. If I have another line here, this is also the horizontal plane. They're just in 2 locations. Does that make sense? Okay. So what we're looking at here is we want to find surface 1, 2, 3, 4. We want to see this surface in its true size and shape. So as I'm looking in my top view, well, 1, 2, 3, 4, this definitely looks like a rectangle, and I can definitely see in that right side, or that isometric view, that it is definitely much bigger than that. So we need to determine how big it actually is. So I have my fold lines in. My corners are labeled 1, 2, 3, 4. Now, if I look, I go 1, 2, 3, 4, and I want counterclockwise. It does not matter how you label them, but it usually is very helpful to label them. But if you notice, 1 is underneath 4, right? So in the front view, we put 4 up top and 1. So we know that as we're looking in that line, number 1 is the first point, 4 sits behind it. And the same thing with 2 and 3. So we know 0.2, zoom out a little bit here. That 0.2 sits in front of 0.3 as I'm looking at it, because here's 2, here's 3. So right in the front is 0.2, sitting behind that is 0.3. All right. So now we want to project at 90 degrees. So I'm going to, these aren't really 90 degrees, but I'm going to do the best I can. So I'm going to use red to show that. And I'm going to project out there at 90 degrees. Now in AutoCAD, what we would do is we would, and we can, I'm just looking at that, so that's not parallel. In AutoCAD, what I would do is I would start by drawing a line, and I would pick out here someplace. Like for example, I might pick here and then say, okay, I want to draw a line that is perpendicular to this surface by typing PERP, and it'll automatically make it perpendicular. So I'm going to show you that here. And I'm going to share my screen. See which one am I on? So here's that same drawing. I would say, okay, I want to draw a line. I would select out here anywhere, you know, and actually I'm going to change layers so it's easier to see, because that construction line is terrible to see. And I'm going to go line, and I'm picking clear down here intentionally because I just want you to see what's going to happen. And then I'm going to type in for my second point, because it's telling me what's the second point. I'm going to type PERP for perpendicular. Now, as I move over that line, notice that little green square symbol that's showing up like right about here. If you look and you'll see it, it's telling me that's the perpendicular point. So when I click and say, okay, it drew that line. Now this line right here and this line here are 90 degrees. So if I'm not sure of that, I can double check that. And I can say, okay, the angle, oops, not aligned, angle. From here to here, that is 90 degrees. So I know that it is true perpendicular. So now that I have that, now what I would do is I would just move that line from end to end and copy the other line. So those lie right on points 1 and 4, 2 and 3. That make more sense? Okay, so I'm going to go back to the camera here. So now what I'm going to do using AutoCAD is I can throw some dimensions on there. I can see that in my top view here that it is 1 inch. So I know it's going to be 1. So I have my fold line right here, and I'm going to not use this fold line because I want my drawing out here a little bit. So I'm going to create my fold line. And I just moved it. And what I really want you to notice is that where you put your fold line doesn't matter. It just, when I move my fold line out, it just moves that view farther away from my drawing. With my fold line being right here, the distance between the fold line and point 2 is going to be the same distance from the fold line to point 2. I'm just moving it out to get a little more room. So now what I'm going to do is I'm going to measure. And as I measure that and say, okay, that is 1/2 inch. Okay, you know, here's a half, and here's 1. It's a little more difficult to see if I try a different. That's easier, 1/2 inch. So then I'm going to come down to the same side. I'm going to measure from my fold line. I'm going to go out a 1/2 inch, and I'm going to make my point. Now that point was point number 2, so I'm going to mark that. I know that point 2 and point 1 are the same distance. So I would measure from my fold line. I'm going to fix my fold line here. That way they're a little more parallel. I would measure again and say there's a 1/2 inch. That was point number 1, so I'm going to label that point number 1. If point 1 and 2 connect in this view, then they also must connect in this view. Now, I know the distance is 1 inch from 2 and 3, so the distance between 3 and the fold line is 1 3/4 inches, right? Because we already said that this dimension right here, when we measured it, was, was a 1/2 inch. So we know this has to be 1 1/2. So then going back to my fold line, measuring a 1/2 inch, 1.5 inches, that's point number 3. 1.5 inches. There's point number 4. Point 3 and 4 have to connect. So there would be my drawing. Now if I go into AutoCAD and do that same thing real quick, and let's share the screen again. And I'm just moving this out, doing the same thing I did before. Again, you don't have to do that. We could use that fold line right where it is. And I'm just going to use the geometry that I have. I'm going to throw a dimension in here so I can figure out that dimension because I don't have to use a ruler. I can say, okay, that dimension right there is a 1/2 inch. So I'm going to offset a 1/2 inch. And I know that there's point 2. And there's point 1 right there. I know it's a 1/2 inch, so in AutoCAD it makes it even easier because all I have to do is offset 1 inch, right? It's doing the same thing, so I'm just going to offset that 1 inch. It would be the same thing as measuring 1 inch. So I know that point number 3 is right there, and point 4 is right there. All I have to do now is fillet this. Change that to the proper layer. And I now know that that is the true size and shape of that surface, and that surface that I was looking for is right here. That doesn't seem too difficult, does it? Now, we went through a lot of steps. Now, I would look at it and say, well, hey, if I just knew this distance right here and said, if I knew, oh snap, if I knew that distance was 2.12 and I knew that this distance is, I could draw that myself. You're absolutely right, you can, okay? But this is when we don't necessarily always know what those true size and shapes are. So looking at our drawing number 2, we have something that looks a little bit different. Now again, we have this surface right here. Now this surface looks a little bit different, but what we can't tell is that this surface right here is on an angle. So it's not flat. I'm going to try something else real quick here that you guys can't see. Where are you? That's not working. I'm trying to switch my cameras and I know why it's not working, because it's in use. So I'm trying to fire up a different way to show you my camera. There it is, perfect. This will work even better than before. So we're going to take, I'm going to share my screen with you again. I can't tell which one you can see. Are you looking at my camera? No, you're looking at my cat or camera?
Camera.
What's that?
Camera.
Perfect. Thank you. So again, we're trying to find the locations, or we're looking at this surface, and we know that this surface, there's an angle on that. So that's the problem that we're dealing with. So we still have our fold lines, right? We need to determine what they are. So we're going to measure our distances between the fold line in number 2, the fold line in number 3, 1 and 4, and do the same thing. So as we project up, simple 3-view drawings, we know that point 3 and 4 line up, and when we see them in the top view, to see this edge, when we're looking for this edge right here on its edge, and in the top view, here it is. So this is our edge view.
What's up? You bring the shims back up to full bar, or is this just...
Say that again. Jacob, was that you that had something to say?
Oh, sorry. Someone came in and was talking to me.
No, oh, that's okay. I just didn't know if you had a question. So everybody understands where the edge view is coming from. We got our edge view that we're trying to find. We have that edge view. So we see that line 1, 2. We see that in its true size or its true length, not its true size and shape, but its true length. Because here is line 1, 2 also, and line 1, 2 is not really that long, but we know, shoot, it's got to be much longer. So hopefully this helps. So doing the same exact thing, I've got to project up. So I'm projecting to the fold line. So I'm looking for this distance. So in the top view, I've got to be perpendicular. So perpendicular. I'm drawing out my edge view. And I drew my lines out extra long because I don't want to run out of space. So I've got to find points 1, 2, 3, and 4. So I'm going back 2 fold lines. 1, 2. So I'm measuring from the fold line, and we'll start and go with number 1. So looking for number 1, I'm measuring and I say, hey, that is a 1/2 inch. So I know point 1 has to be on this line. So measuring from my fold line, I'm going to go over again, and that's going to be, there's point number 1. Going in order, so now I'm going to try and find point number 2, measuring down, say, hey, that's 3/4. So I know point number 2 has to be on this line because that's where it touches. So I'm going to come up here. Point number 2 is at 3/4. So there's point number 2. Point number 3 is on the same line as point 2. Measuring that out. Okay, that is 1.5 inches. So going over here, measuring 1.5 inches. Point number 3. Just double checking my dimensions. And if number 3 is 1.5 inches, number 4 is also going to have to be 1.5 inches. So come down measuring, 1.5 inches. There's point number 4. Now when I draw my lines or connect the lines, we see that there is now my true size and shape of the surface. So it's really simple. As long as we go back and measure one fold line, we'll be able to find those. I'm going to pop over to AutoCAD real quick. And here's the same thing. Again, drawing my line perpendicular to it. Hate that yellow. I didn't create this drawing. Someone else did it for us. So I'm just going to copy it from the ends. Does everybody understand why we're going to the ends of those lines? Okay, and I'm going to use this cheat here, and I know that the first one, what we say, was 1/2 inch. So the distance between the fold line, so just to double check real quick. Okay, and say here to here was, can't really see that. We'll switch that in just a second here. There, 3/4 and 1/2. So I'm going to offset 0.5. So I know that is, and now I'm going to start cheating a little bit by using my fillet command. So I know that point right there is point number 1. I'm going to offset, we said 1.5 inches, because that was the distance from my fold line down to 0.4 and 0.3. I'm going to fillet. So I know I have, oops, come on now. Point number 1, point number 4. I know point number 3 and 3 and 4 on the same line, so I already have number 3 found. So I can fillet that. Now I just have that 1/2 inch from the fold line to point number 2. I'm sorry, 3/4 inch, because I'm looking for point number 2. It's 3/4 inch. So we're going to offset 0.75. I'm going to fillet this, even though I'm not really going to use it, because I know there's point number 2. And I'm just going to move the end of that line there. I'll delete that. So I know that I have the true size and shape of point 1, 2, 3, 4, which matches here. And I took that from the distance. Remember, 1 line, 2 lines, and here's where my measurement comes. And I have to use this view because that's where I see the edge in its true view. Now, I could also use this edge. It's a little more difficult because I don't have it drawn, but I do have an edge view in length. So now I can determine what it is. Does that make sense? So you're going to have, sharing another screen with you. We're looking at Blackboard now. Okay, so the PowerPoint, the notes, what we already talked over, 7.1 and 7.2 that I gave to you. So you're just submitting the drawing that I just did with you. Okay, and you can use this video to walk through if that you need help with that. So that would be what we would have done on day number 1. day number 2 or the second half of the class is a little more difficult drawing that I'm not a fan of, so I'm skipping it. So now we're going to go to week 12, day number 1, and we have the holder pivot. This is drawing number 15. And this is the holder pivot. Not what the hell, whatever. This is really quite simple. Okay, so this is we're already kind of showing you what it's going to look like. So we need to see everything in its true size and shape, right? So we're looking at an edge view here. So this edge is this edge. So we're just using that same information. So this, you get this. You're going to draw the front view as an edge of this view or of this drawing. So what we're looking at here is we want to be able to see this edge here and this edge here in its true size and shape. If we try to rotate this to a front view, that whole view is going to be foreshortened and it's going to look really goofy. So that's not going to work for us. All right, so what I'm going to do now is I'm going to pop back into my other screen. Well, actually, you know what? I'll just bring AutoCAD over here. And I actually have the holder pivot started. Okay, a couple of things I want to show you. So this we could draw, right? Based off from what we have here. And I'm going to snippet this and put it in there. So based on this information, we could actually get this view, right? Feel pretty confident you guys could do that? I do too. Now, some things that we want to look at. If I try to draw the left side and the right side view and the top view, again, they're going to be foreshortened. So with drawings like this, what we do is we do a partial top view. So in that partial top view, I drew everything that I could see in the top view, and then I tore off. So this is a pain in the butt to draw. So you don't have to draw it like this. You can make those lines much more jagged than I did. What I drew is the way we used to have to do it with paper and pencil, and it was make it look like a torn piece of paper. We're not really, the other thing that you could do with that, if you remember you could take a line and then do this. We could do that same thing. And then erase this. It would be exactly the same thing. I just really like this because it's just what I used to do. And I have a little block that I use, and I just copy and paste it and insert it, so I use it. But I don't expect you don't have to do that. So I have my top view, and I could get my top view from the information that I have, right? 3/4 hole. I know that there's an 1/8 inch fillet right here. So when I put that fillet in, I can project that up. Turn my ortho on. So we see where those project. Now, if I had that and I had a line that was from my midpoint, I would use a 2-point. I would use a 2-point circle, and I would say, okay, I'm going to use a 2-point, and I would go from the intersection of that to the intersection over here and create that. So you don't actually have to measure. You can just use geometry. So I have a hole in the top view, therefore I have to have that hole in the front view. The bottom, again, I get the same information. top to bottom. Now, I want to draw this left side view. So the first thing I have to do is I have to create, let me move this fellow a little bit here. I've got to create my auxiliary view or my projection lines. So I've created those already. And I'm going to turn those bad boys on. So there's my projection lines. So I projected them at 90 degrees. Each one's a little bit different because these are not the same angle. So I just went line, perpendicular. I knew I was going to grab the edge. I know that there's a circle coming through here, and I have that information. So I could project those out and get those. Okay, I know where they are. So as we're looking at the information here, we're saying, okay, I know that it's up 7/16, or 1 7/16 to the top. From here up to here is 1 7/16. So on my drawing, I did the same thing. I just offset 1 7/16. There it is. Just so I did use this view up here. I needed this information to create the view. So instead of talking about the left, we'll go to the right. So with my right side view, I'll turn that on. So with those projected, again, I just offset. Now, I don't have to use a fold line. So understand, we went to the whole fold line things, and now you can say, well, Mr. Ward, you're not using fold lines. I mean, I can. We could put fold lines in there, but then we'd have to have that partial top view. But realistically, when we have a drawing like we have here, I have the information. I don't need to go. We would use those fold lines when I don't know. An example of this that with the fold lines is my EG110 class. They have a pyramid. In that pyramid, they've got to determine how big all of the sides of the triangle are. And all they get is the top view, which looks like a square with an X. And they see the front view, which looks like a triangle. And they have to figure out the true size and shape of all 4 sides. Well, the only way they can do that is through true link lines. And don't worry, Rose, I'm not going to make you do that. But that's what they have to do. And they have to have those fold lines because they don't have any other numbers. All they have is the drawing itself. So there's no numbers that they can look and reference. They have to use the fold lines to determine that information. So we have the information, so we don't have to worry so much about using those fold lines in this case. So we can just simply draw them. If we remember, it has to be at 90 degrees. So I drew my lines up at 90 degrees, and then I just projected, and I just offset and said, how far do I want this to be? I just moved it up. Now, this view right here could be farther up or down. It doesn't matter. So I drew my edges and just used the information that I took from my drawing. I knew that my center, I just picked the center. And that's really where I started, was with the center and offset, because I knew it was an inch, it was 15/16. So I offset 1 15/16, offset 1 15/16. Boom, there's my width. And I just worked off the center. So here's that hard edge that we see here. And I'm going to turn off my 90-degree lines. So I see this edge, which is this point. And I'm still going to have a little bit of material that's going to show. I don't just stop it with a line and say there. I still want to show that breakaway that, hey, there's more drawing to it, but we're not showing it. We're showing you just that flat edge. So with this flat edge, we can now take the dimensions that are on here and we can dimension this part so someone else could actually lay that out and draw that where it is. Looking at the left side, doing the same thing on the left-hand side. Now when I turn that on, I've got the same thing going on here, where I knew it was 15/16 from the center out. And rather than trying to calculate how big that was, I just went up into tangent, 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 because I knew that these were 15/16 from the center to each edge, just like it said in my drawing. Slide this over a little bit here. Come on. Right here, I can see that it's 15/16 from the center down. Well, it's 15/16 from the center down, then it has to be to each edge. So then I just went over and said, okay, I know where those are, because I projected that edge up and went tangent, 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 and just selected this edge, this edge. And as soon as I selected this edge, we won't be able to see it now. Actually, we will. when I pop it in, there's that circle. And then I just trimmed it out because it was there. So I'll delete that. And then I knew that I had this 9/16 hole, which I drew in my front view, and I just projected it up, did the same exact thing. I did a 2-point circle, intersection, intersection. There it was. I didn't even measure it just because I'd already had it drawn in the front view. Turning off my 90-degree lines again. I have my front view. I still have my breakaway because I can see part of that edge. Now the important thing here is not above this edge. This is the surface. So that edge right there represents this surface. So that's what we're trying to get to. So I can see that in its true size and shape, as though I was able to rotate it flat so I could draw on it, mark it up, so that someone who's working in the shop would be able to lay that out and put that information in place. Now, the last thing that you're going to do with this drawing is you're going to dimension it. Okay, and remember that when we dimension, there are 3 things that we have to focus on. Okay, and what are those 3 things that we need to focus on? I'm going to stop sharing my screen here. 3 things we got to focus on. What are they? I need your help.
Where it is, how deep it is, and I don't remember the other one.
Right. Where is it? How big is it?
How big it is.
So location, size, and depth. So we want to make sure that we have all of those things in place. I just had some other notes of things here that I wanted to cover to make sure that we got everything. Make sure that when we're turning in our drawings, make sure you're turning in the right drawings to the right location. I'm having some issue, and it's not your issue, it's my issue. That, you know, when you submit something and it's the wrong drawing in the wrong location, and you say, well, I'll email it to you. That's really fine, but I can't mark it up then. And then I just had Jake, I think you're the one that emailed me and said, hey, you're ever going to get a test 2 graded? And it was literally 3 pages down. There were 120 emails that had come in since you sent that. And I'm just looking at my email going, okay, I only see 40 emails. I'm good. And then I start looking and go, oh, shoot, I got a bunch here I got to get to, because I'm averaging about anywhere from 50 to 70 emails a day, literally, from the college students. And that's my fault. That's not on you guys. That's me. But it's easy for it to get lost. So if it comes up to something, just send me a reminder email. Hey, I'll take a look at it. But what I'm going to try to do is, if you send something like, hey, this is the wrong one, I'm just going to kick it back to you and say, hey, please resubmit this so that I can mark it up. So Jake, hopefully you were able to go back into the drawing, and I did a voice recording to talk through what I had in the email. So it's still the wrong drawing there, but I did a voice recording. So if you're looking at your drawing and listen to that recording, you'll be able to hear the things that I did with that. And of course, zoom. You know, Rosa, I know that you were talking to me about needing some help with 3-view drawings. When you get time, let me know. We'll zoom in.
Okay.
I'll reteach orthographic projection if I have to, because it's important for you to know what it is, because everything we're going to do is going to keep building off those same concepts.
Okay.
So you guys have issues. It's just faster and easier. That, you know, I can use paper, I can use AutoCAD, I can do it on my end, we can do it on your end with, you know, using your screen. It doesn't matter. But, you know, these are all things that we need to make sure that we have a firm understanding by the time we get to the final, which is in 3 weeks. You know, we have this week, next week,
Wow.
you know, and then we're getting right to the end quick. So far, the only thing we have left to cover after auxiliary views, we have cross sections, and then we have hole types, but we'll do hole types and cross section at the same time. And then we have threads and fasteners, and that's it. And we're at the final. You know, so we have a lot going quick. So expect next week to be a little bit longer as well, because next week we jump right into cross sections. So we only have this 1 week where we spend on auxiliary views, and auxiliary views are not on the final exam. That's something that we'll expand upon once we get into DR 229. We'll get into auxiliary views. So, you know, it's not going to be on the final, but it is something you need to understand. but cross-section is on the final. So we'll want to make sure that we have a firm understanding on how to do those. All right? Questions from anything? I know we covered a lot, but thank goodness it's recorded so we can go back and watch it if you need to. But does anybody have any questions moving forward with anything?
No, not until I actually get into it and start trying to draw something.
Just let me know.
It seems to make sense now.
Well, you know, this is a night class, so I know I said 8 o'clock, but that doesn't pertain to you guys. So you guys have my attention until, you know, about 10 o'clock. You guys have my attention, that, especially on Monday nights anyway. 10 o'clock on Monday nights, I'm all yours. You guys can let me know, and I'll pop in and do what I can do to help you guys. All right?
Cool.
Cool.
So other than that, that's all we have for this week, and then we'll meet up again next week with our Zoom meeting. And then you have week 11 and then day 1 of week 12, which is all auxiliary views for your drawings for next week. Okay?
Thank
All
you.
right.
Yep, thanks.
Stay safe. Stay healthy. We'll talk to you soon.
Thank you.
You bet.